Hello, this is Mrs. Brown, and today we're going to be looking at how to solve x squared plus bx plus c equals 0. Before we can actually get to the solving, we've got to learn how to factor these trinomials. Now, it's not the same as factoring out the GCF as we've been practicing. So we're going to take a look at some examples of that and then look at how we solve by graphing, because once we have it factored into two binomials, we'll be able to do the way we did before, setting an equation equal to 0, like here, and then finding what makes those two binomials 0. Okay, so basically when we're factoring, we're looking for two integers, so that means they could be positive or negative, but we're not talking fractions or decimals, with a sum of b, so they have to add together for the middle term, and a product of c, so they multiply together to give me c. And those are my two clues that's going to allow me to write the binomial. Okay, and then we're going to write it as these two binomials. Okay, and this is the same thing in symbols. And then if we take a look at an example, so let's say at x squared plus 8x plus 15. If I look at 15, 3 times 5 is 15, and 3 plus 5 is 8. So this factored would look like x plus 3 and x plus 5. Okay, so if you need to, you can take a moment to pause and write that down. And let's look at some different cases, because there's actually 3 different cases that could happen. And it's good to kind of have these summarized so that you have that information. Okay, so the first case is the one we just looked at, which is B and C are both positive. The second one is where B is negative, but C is positive. And as you look at that form, x minus b times x plus c, what happens is a negative times a negative is a positive. So they're both minus. When you have c is negative, then that means that you have one minus and one plus, and we'll take a look at how to deal with that when we get there. Okay, but this is just good to know the 3 different kind of cases. Again, I would pause and write this down, because this is good to have this summarized so that when you're trying to do your work, that you can kind of reference this. Okay, all right, so let's take a look at some examples. Like, how do we actually do this? What am I going to do to try to figure this out? Okay, and I'm going to show you basically how I would show my work. And again, you are expected to show your work on this assignment, and how I would set that up. Okay, so let's say I had x squared plus 7x plus 12. Okay, and I want to be able to factor this into two binomials. So I know that those two things have to multiply together to give me 12. So I'm going to list the factors of 12, like 1 times 12, 2 times 6, 3 times 4. And then what I'm doing is I'm looking for which pair of those factors add together to give me 7. So like 1 plus 12, for instance, is 13. So that's too much. 2 plus 6 is 8. That's not going to work. But 3 plus 4 is 7. Ding, ding, ding. I've got a sum of 7 and a product of 12. And so if I were factoring this, these are both positives. So I'm going to be plus on both of them. And it's going to be 3 and 4. Okay. You can always check if you're not sure you did it correctly by actually multiplying it back out to see if it comes out to this. So for instance, we can do our double distribution. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. And when I combine like terms, I end up with my 7x plus 12. Okay, so this does match here, which means I did it correctly. This is the answer that we're looking for. This is the factored form of this quadratic. Okay, and remember, quadratic is referring to a degree of 2. Okay. So let's take a look at another example. Okay, I highly recommend that you write out your factors like I'm doing. It makes it easier to see. You're less likely to make mistakes. You're going to strengthen your ability to visualize things. You don't necessarily have to write out the sum of all of them, because once you have the products the factors listed, it's kind of easy to pick out which one is going to be. So for instance, like 1 times 24 is going to be way too much because that's going to be 25 when I add them together. But 2 and 12, 3 and 8, 4 and 6. When I look at this, for instance, 2 plus 12 is 14. 3 plus 8 is going to be 11, which is the one I want. 4 plus 6 is 10. Again, I don't necessarily have to write all of these out because I know this works. Okay? They're both positive. That's what we've been looking at. So x plus, okay, and 3 and 8. Now, it doesn't actually matter which binomial you list first. So if I listed it as x plus 8 and x plus 3, that is equally correct because of the commutative property of multiplication. Remember, this means this times this, so it doesn't matter which group I put first. I'm multiplying, so the order doesn't matter. Okay, so either of those would be considered correct. Okay, again, C is the last term, and so I'm looking for those factors of C. This is where, if you're really comfortable with your multiplication facts, it's going to be much, much easier for you to do this than if you're somebody who's a little bit shaky. Okay, so let's look at one more example of when they're both positive, and then we're going to look at some other examples. Okay, so when I take a look at this one, again, I'm going to go with 18. I'm going to look at the factors, 1 and 18, 2 times 9, 3 times 6. Like 2 plus 9 is 11, and 3 plus 6 is 9. This is the one I want because the sum of the factors comes out to B, which is the middle term. That's why I'm lining the multiplication under C and lining the addition under B. And as before, I'm just filling in that information. Once I figured out which ones work, it's real easy just to write the answer. Okay, so let's look at what happens when B is negative. Okay, they're both going to be minus. So if I have x squared minus 21x plus 20, okay, I'm going to do exactly what I just did. I'm going to take 20. I'm looking for factors that multiply together to give me 20. So 1 times 20, 2 times 10, 4 times 5. And then I want to see which ones add together to give me 21. Well, 1 plus 20 is 21, so therefore this works. Okay, 2 plus 10 is only 12, and 4 plus 5 is only 9. This works. My only difference from what I just did, because C is positive and B is negative, this is really important, C is positive, okay, is just going to be putting minus signs instead of plus signs. And my numbers are 1 and 20. So it's going to look like that. Again, it's exactly like the ones I just did, but because this is minus, this is still plus, C is still positive, it's going to be minus minus, because a minus 1 times a minus 20 or negative 1 times a negative 20 is going to be a positive 20. So that's how that's going to get out, get to be positive there, and this has to stay negative because it's going to be like negative 20x minus 1x. And so that's the only way, is if both of these are minus, that C is going to be positive and B is going to be negative. Okay, so let's take a look at another example. Okay, so again, first step, take C, looking for factors. 1 times 30, 2 times 15, 3 times 10, 5 times 6. So we're looking for two things that when you multiply together to give you 30. Looking at this, 2 plus 15, for instance, 17, that's not going to work, but 3 plus 10 is 13. So these are my common factors. Again, C is positive, B is negative. So that means I'm going to use minus signs. Okay, I substitute in my two factors. And again, if you're uncomfortable, you're not sure you did it right, you can just do your double distribution and check to see if you get back to the original problem. But this is the answer we're looking for, the factored form of this trinomial. Okay. So now let's look at what happens when C is negative. Okay. So what do we do in this case? Okay. Now you can deal with negatives and continue to do addition, but here's what I'm going to tell you. I think about it as a difference instead. Instead of trying to figure out like negatives and all that stuff, I find it a lot easier just to think about it that the middle term is a difference. So B is a difference instead of a sum. Okay. And we can look at why that is when we do our first example. Okay. So x squared plus, and in fact, let me move this over because I want to do the difference between these two problems. Okay. If you look at these two problems, the difference is B is positive here and B is negative here. So I want to look at what is happening in each of those cases so you can see the difference. Okay. So I'm going to start out just like I always did with the other problems and look for factors of 12. So 1 times 12, 2 times 6, 3 times 4. Now, instead of finding a sum, because this is a minus, I want a difference. And so when I look at that, 12 minus 1 is 11, 6 minus 2 is 4, which I want, and you can see 4 minus 3 is 1. This is the one that works. Okay. If I do the same thing over here, I come out with the same outcome. I'm still looking for 4, so it's still 6 minus 2. But when I write the problem, when C is negative, the only way that's going to happen is if one is positive and one is negative. Because if they're both negative, it's going to cancel. So I have to have one positive and one negative. So if B is positive, the bigger number is positive. So between 6 and 2, 6 has to be positive and 2 has to be the minus. Otherwise, it won't come out. The difference for this one, and I don't know why I wrote that one freakishly big, when I look here, because B is negative, I'm still using the 6 and 2. That comes out correctly, except this time the bigger number has to be the minus because I have a negative B. So looking at these two questions, the process is identical. The only difference is since B is positive, the bigger number is with positive. Since B is negative, the bigger number is on the negative. Okay, and let's make a note like in a different color. So B is positive. So larger number or larger factor is with the plus sign. Okay, so you can see that the larger number is with a plus sign. When we look here, B is negative. So larger number is with the minus sign. Okay. And again, if you want to, you can go ahead and pause and write that down if you need to. Okay. I want to show you why we're doing 1 plus and 1 minus, just taking this and multiplying it back out so that you can see why it's a difference instead of a sum when I think about it this way. X times x is x squared. X times minus 2 is minus 2x. 6 times x is 6x. And then 6 times minus 2 is minus 12. What happens is I've got a negative 2x and a 6x. So when I combine like terms, I'm really doing 6 minus 2, which is 4. Okay. And that's why we do a difference, because they're going to end up as opposite signs. One's going to be positive and one's going to be negative. So effectively, we're subtracting them. Okay. All right. So let's take a look at another one of those examples. Okay. And again, I want to do two different problems so that you can see. That is the one I just did, isn't it? Yes. Okay. X squared plus 5x minus 36, and x squared minus 5x minus 36. So again, I want to look at how these two answers are going to differ. It's very minor. Here b is positive, here b is negative, but c is negative in both of them. Okay, again, I'm going to look at my factors of 36. So we're at 3. 3 times 12, 4 times 9, and 6 times 6. Okay, and then I'm looking for ones, again, c is negative, so I'm looking for a difference instead. Obviously, that's too big, that's too big, that's too big. If I go down here, 9 minus 4 is 5, which is what I want. So I know because c is negative, one's going to be plus and one's going to be minus. And since b is positive, the larger factor has to be with a plus sign. So between 4 and 9, it has to be 9. If I do the same thing over here, okay, it's the same factors over again. It's still going to be 9 minus 4 is 5. But when I actually write the problem out, because it's a minus b, the bigger number has to go with a subtraction sign. And that's the difference. Okay. So the last thing I want to look at, because those are the different types, is actually solving by factoring. Okay. And this is just taking this skill and putting it with a skill that we learned last time. So if I take the problem, x squared plus 9x plus 14 equals 0, my first step is to do exactly like I just did. Okay. I look at the factors of 14. 1 times 14, 2 times 7. That's about it. These are both addition, so this is a sum because c is positive, so I'm just adding. 1 plus 14 is way too much, but 2 plus 7 is 9. So this is my factors, okay? Or this are my factors, okay? So these are my factors. Jeez, the grammar. Okay. When I look at this, then it's going to be 2 plus x plus 2 and x plus 7. Okay, there's 2 and 7. They're both positive, so they're both plus signs. Okay, now remember, to solve, I'm just going to take each of these binomials and make them equal to 0. So it's going to be this or this, because in order to get to 0, one of these two has to come out to 0. So I check both cases. Subtract 2, you get x equals negative 2. Subtract 7, x equals negative 7. So my roots or answers to this are going to be negative 2 and negative 7. So it's taking this skill that we just practiced, factoring it into two binomials, and once you have the two binomials, you can find the roots just like we did in the previous lesson. Okay? So let's take a look at one more example, and we'll call it good for today. So x squared plus 2x minus 15 equals 0. You should be noticing that c is negative, which means one's going to be plus and one's going to be minus, and this is going to be a difference instead. I start out the same, 1 times 15, 3 times 5. Those are the factors of 15. I need a difference of 2, so 5 minus 3 is 2. So 5 and 3 are my two factors. I know one's plus and one's minus because c is negative. B is positive, so the larger of the two factors has to be with the plus. So 5 goes here and 3 goes here. Once I've done that, it's equal to 0. And I just set each binomial equal to 0. Okay, so in this case, when you subtract 5, you get x is negative 5. And when you add 3, you get x equals positive 3. So my roots are negative 5 and positive 3. I hope this helps. Have a fabulous day, and I'll talk to you soon.